Hi students, welcome back to my channel. In today's episode, we'll explore the rationalizations of complex numbers and tackle some DSC style questions at the end of the lesson. Previously, we introduced the definition of complex numbers and their basic operations. There are some small but important details I want to cover before we dive into today's main topics. We all know that complex numbers consist of real parts and imaginary parts. For example, in the complex number a plus bi, a represents the real part while b is the imaginary part. Example 1, the complex numbers are not presented in the standard form of a plus bi. We need to simplify the expression a bit before we can identify the real and the imaginary parts. In part A, for 3i minus 5, the real part is -5. For imaginary part is 3. Please note that 3i is an imaginary number, but when we refer the imaginary parts, we just write the number before the I. Okay, in part B, we separate the fractions. -7 over 3 plus 4i over 3. So the real part is -7 over 3, while the imaginary part is 4 over 3. Let's see some examples. In question 2, we convert the denominators of the following to real numbers. Okay, the aim is to change the denominator to real number. Please look that in part A and part B, the denominators are imaginary numbers. For this type of expressions, we can simply type I over I. For I is 1. Of course, we can multiply 1 to the original expressions. The value will not change. Once we multiply I over I, please notice the denominator. It will become 2i squared. Because I squared is -1, so the denominator will become -2, which is a real number. The aim of these questions is to change the denominator to real number. So we are done. Now we simplify the numerator now, as 7 plus I times I will become 7i plus I squared. Square is -1. We usually put the real part in the beginning and 7i at the end. Okay, so the answer is -1 plus 7i over -2. In part B, we are going to use the same method. That's time I over I, but we need to tackle the negative sign before that. Okay, please pay attention that the negative sign can either belongs to the numerator or the denominators. Okay, you can put it either way. Okay, perhaps we put it in the bottom. Okay, so that is -3i, 2i plus 1 times I over I. Okay, we write the denominator first, -3i squared. Because I squared is -1, so the denominator becomes 3. Okay, the numerator 2i squared plus 1i. 1i is I squared is equal to -1, so there is -2 plus I. Okay, finish. In part C and part D, the denominators are complex number. They are different from part A and part B. In part A and part B, the denominators are complex number, has no real part. But in part C and part D, they have real parts and imaginary parts. We do the rationalizations. There are two types of complex number. The first type is something over a plus bi, or something over a minus bi. For the first case, we multiply a minus bi over a minus bi. For the second case, times a plus bi, a plus bi. Once we do that, the denominators will become real numbers. Okay, we see the effect from the examples. We try to concentrate on the denominator. Okay, 2 plus 5i over 5 minus 2i. 5 minus 2i, so at time 5 plus 2i over 5 plus 2i. Okay, the denominator, it is in the form a minus b times a plus b. So that is 5 square minus 2i whole square. Okay, so the denominator will become 5 minus 4i square. Square is equal to negative 1, so it is equal to 5 plus 4. Okay, so you see that the denominator become a real number. Okay, now we multiply the numerator. 2 plus 5i times 5 plus 2i. Okay, so there will be 4 terms. 10 plus 4i plus 25i plus 10i square. Okay, the denominator become 9. Okay, 10 and 10i square is negative 10, so they cancel. 4i plus 25i is 29i. Okay, so the answer is 29i over 9. Okay, in part D, we try to concentrate on the denominator. The denominator is root 5 minus root 3i. So it is in the form of a minus bi, the denominator I mean. So we need to multiply root 5 plus root 3i, root 5 plus root 3i. Okay, the denominator will become root 5 square minus root 3i square. Okay, so the denominator become 5 minus 9i square. 9i square is positive 9, so the denominator become 14. We handle the numerator now. Okay, the product of them is 5. It become root 15i. At last 9i square. Okay, 5 minus 9 is negative 4, and plus 2 root 15i. See that there's a common factor of 2 in the numerator. We can take outside. Over 14 and cancel with the 14 in the bottom. So the answer is negative 2 plus root 15i over 7. Okay, in part E, we are going to do a subtraction of complex number in fractional form. If they are in real number, okay, for example, 1 over x plus 4 minus 3 over 4x minus 1, we can multiply the denominator. Will become 1 times 4x minus 1 minus 3 times x plus 4. You may think of the same method on these questions, but it is not the case. For complex number, we need to rationalize the individual complex number. Okay, so actually, how do we do that? 3 minus i, 1 plus 4i. We rationalize this complex number. So 1 minus 4i, 1 minus 4i. Okay, for the second complex number, 4 minus i with time 4 plus i, 4 plus i. Okay, then the next steps become 1 square minus 4i square. The numerator 3 minus i 1 minus 4i minus, okay, 4 square minus I square, I times 4 plus I. The first complex number, 1 minus negative 16, so 1 plus 16 is 17. Okay, the numerator 3 minus 12i. Okay, and then minus I, and then plus 4i squared. For the second terms, 16 minus negative 1, 17. Okay, 4i plus I squared. Okay, the denominator become real numbers, and luckily they are the same. So we have the same denominator. Okay, so we copy everything down. So 3 plus 4i squared is negative 1, and then negative 13i minus 4i. Okay, and then minus I squared. Okay, please notice that this guy, negative I squared, is positive 1. Cancel the negative 1. Okay, so that's negative 17i over 17. Cancel the 17. The answer is negative I. Okay, in question 3, find the real part of this complex number. Now, to solve this question, we need to do 3 things. Okay, the first thing is to rationalize this complex number. Second, we notice that there are some higher power of I in the numerator. We need to bring down the higher power. Okay, we mentioned it that I to the power 4 is 1. We will use this to change the numerator to become a normal complex number. At last, we will separate the real part and the imaginary parts. The question just asks the real parts. Okay, first thing first, perhaps we simplify the numerator. Okay, 3i to the power 16 times I squared plus 2i to the power 16 times I minus I to the power 16. Okay, because I to the power 4 is equal to 1, I to the power 16 is the same, is equal to 1. So it will become 3i squared plus 2i minus 1 over 1 minus I. Okay, so this one is negative 3. So negative 4 plus 2i, 1 minus I. Okay, the denominator is 1 minus I. So we time 1 plus I over 1 plus I. Okay, and then the denominator will become 1 squared minus I squared minus 4 plus 2i, 1 plus I. Okay, so negative 4 minus 4i plus 2i plus 2i squared. Okay, numerator will become 2. Okay, numerator become 2. So negative 4 and negative 2 become negative 6 and minus 2i and 2. And obviously, there's a common factor of 2. Take outside, negative 3 minus I, 2 cancel. So the answer is negative 3 minus I.